For years, something was off with our sun. It was a genuine mystery for scientists. So today, let's play detective and unpack the case of the quiet sun.
So, why was our sun so quiet? It sounds like a simple question, right? But it gets to the very heart of how our solar system works. I mean, this is the sun we're talking about. It's supposed to be this ball of fiery, constant activity. So for it to suddenly go quiet, well, that was a huge puzzle. And we're not talking about a small dip here. Solar cycle 24 was the weakest one we've seen in a century. It came after this really long, deep, quiet period that just left our best computer models totally scratching their heads. To figure out what went wrong, we first have to understand the rules the sun is supposed to play by. Okay, so let's get into the sun's magnetic heartbeat. The best way to think about it is like a rhythmic pulse. It's this constant cycle of activity ramping up and then calming down. And that cycle pretty much dictates space weather for all of us here in the solar system. So here's the basic breakdown. The sun runs on this roughly 11-year cycle. Its activity, which we mostly see as sunspots, kind of ebbs and flows. Now the really crucial part is this. The magnetic fields at the sun's poles during the quiet time, they act like a seed for the next cycle. So it's pretty simple. A weak seed means you're going to get a weak cycle. That's one of the fundamental rules. And for a long time, scientists had a pretty reliable rule book for all this. It's called Joy's Law. Basically, it said that sunspots, which are really just pairs of magnetic poles, will always have a predictable magnetic tilt. And that tilt depends on their latitude, how far they are from the sun's equator. This tilt is everything, because it's what lets that magnetic energy travel up to the poles and build the seed for the next cycle. You could say Joy's Law was the bedrock of all our solar predictions.
All right, but this is where the mystery really deepens. Because when scientists took all these established rules, everything we thought we knew, and plugged them into their super powerful computer models, well, something went very, very wrong.
So, this is what the forecast looked like. Based on Joy's Law, the models predicted this nice, orderly march of magnetic fields toward the poles. Everything looked good, forecasting a strong buildup for the next cycle. This is exactly what everyone expected to see.
But then there was reality. This is what actually happened. The real data from the SOHO spacecraft showed something completely different. It was weaker. It was messier. The polar fields were faint, the patterns all disrupted. The forecast wasn't just a little off, it was a total bust.
So, let that sink in. Our fundamental understanding, the very rule book we'd been using for decades, it just failed. The sun wasn't behaving the way it was supposed to, and that left scientists with a huge question. Were the rules themselves wrong, or did something or something break them? This is where the investigation gets really cool. The scientists decided to try something different. Instead of relying on the old rule book, they decided to just throw it out. They were going to look at the raw evidence, examining every single sunspot one by one. And this turned out to be the breakthrough. They literally rebuilt their simulation from scratch. No more assumptions. Instead of just telling the computer all sunspots follow Joy's Law, they did the hard work. They went back and measured the actual observed magnetic tilt of every single sunspot region from the whole cycle and fed that real-world data into the model.
And wow, the result was stunning. You had the old model, based on the perfect idealized rule, which failed completely. And then you had the new model, built on all that messy real-world data. And it was a perfect match. It perfectly recreated the weak polar fields they had actually observed. The mystery wasn't about some new, undiscovered physics. It was hiding in the data all along. They had found their culprits.
So let's meet one of the main offenders, this big sunspot region right here. What made this one a saboteur wasn't just its size. It was its location, really close to the sun's equator, and more importantly, its magnetic tilt. It was completely backward from what Joy's Law said it should be. So here's how the sabotage went down. A few of these big, rogue sunspot regions popped up right near the equator, and because their magnetic poles were tilted the completely wrong way, they started sending the opposite magnetic charge across the equator. It was like they were actively working against the system, canceling out the good magnetism and basically poisoning the well for the next solar cycle. And the damage they did was just immense. Get this. Just these few rogue spots managed to reduce the buildup of that critical polar field, that all-important seed, by around 40%. Think about that. A few misbehaving rule breakers managed to weaken an entire solar cycle on a star that's 1 million times bigger than our planet. So, okay, the case is solved. But what does this all mean for our ability to predict what our star is going to do next? Well, the answer is kinda both reassuring and, honestly, pretty humbling. When the scientists looked back at the data, they saw that the previous cycles 21 and 22, had pretty much played by the rules. Most of the sunspots followed Joy's law, no problem. So this rogue behavior, the stuff that happened during cycle 23 that led to our weak cycle, it was an anomaly, an exception, not some new permanent rule for the sun.
And that really is the solution to the whole mystery. The fundamental physics of the sun didn't change. We didn't need to throw out all our theories. The quiet sun of solar cycle 24 was caused by, well, dumb luck. Just the random chance that a few badly behaved sunspots showed up in exactly the wrong place at the wrong time.
This leads to a really profound and kind of mind-blowing conclusion from the very scientists who cracked this case. They basically said that because the strength of any future cycle depends so much on the random, unpredictable behavior of just a few key sunspots, making accurate long-term predictions is, and I'm quoting here, virtually impossible.
And that's a powerful thing to think about, isn't it? If we can't fully predict the star we know best, our own sun, it makes you wonder, what else out there in the universe is governed not just by grand, predictable laws, but sometimes by pure random chance?